We are going to determine whether or not the following differential equations are exact or not. And to do that, what we need to know is our Mn. And what I mean by that is if we look at a problem like that, like this, and we want to determine if it is exact or not, we are going to look at the following. So you notice you have a part in front of your dx, that's going to be your m. Anything in front of dx is going to be your m. And anything in front of dy is going to be your n. And this should all be equal to 0. So if we do that for this first one, we're going to take the derivative with respect to y. That means we're going to have a negative 8, because the 2 comes down, x, y, plus just a 1 right here. And this should be equal to, if we take the derivative with respect to x of the next part, a negative 8x, and then we'll have a y plus 1. So these are equal, they are exact. Now we're going to do the same thing for this next one. We're going to have to multiply everything by dx to get this dx to be over here. In doing that though, we're going to take the derivative with respect to y in the first one. So we're essentially going to have a 4e to the x. Now the derivative of sine y is just going to be cosine y, and we'll just have multiplied by 1 because if we do the inside part, it's just going to be 1. Then we'll have a minus, and then since we're taking derivative with respect to y, this will just be 3. We'll have a plus, and then inside of here, we want derivative with respect to x. So we are going to have a negative 3. We are going to have a plus, remember, everything else except for x is a constant, so 4ex cosine y equal to 0. So we can see that for this part, it's going to be equal to this part, and so it is exact. Now let's look at this next one. If we take the derivative with respect to y on the first one, that's going to give us a 2y, and then derivative with respect to the second, or to dx on this next one, we'll have dx equal to 0, and now we can see that this is not exact. So it's not equal to each other, and only the first two are exact, and that's how you would go about looking to see if a differential equation is exact or not.